Today, I'm going to explain how an electric motor works, and trust me, it's simpler than you think. We'll cover a bit of the theory behind it, do some experiments, and finally, we'll build a simple motor to see it all in action. Let's dive in. Let's start with the basics. When an electric current flows through a conductor, it generates a magnetic field around it. This phenomenon is described by Ampere's law, which states that the magnetic field in a closed loop is proportional to the electric current passing through it. To visualize this, we can use the right-hand rule. If you point the thumb of your right hand in the direction of the current flow, the curl of your fingers will show the direction of the magnetic field that surrounds the conductor. In the first experiment, we'll test whether an electric current generates a magnetic field. To do this, we'll build a simple electromagnet by wrapping copper wire around a steel hex key. It's crucial that the wire is stripped of insulation at the points where it connects to the battery. The footage is sped up to keep things interesting. Let's see if it's strong enough to lift a simple paperclip with a metal component. Let's dive back into some theory. Now, what happens when a current-carrying conductor is placed in a magnetic field? It experiences a force known as the Lorentz force. This is described by Fleming's left-hand rule. If you point your thumb in the direction of the current and your index finger in the direction of the magnetic field, your middle finger will point in the direction of the force acting on the conductor. This force causes the conductor to move, and the stronger the current or magnetic field, the greater the force. This is described by the formula, where F is the force, I is the current, L is the length of the conductor, and B is the magnetic field. The symbol times indicates that the force is perpendicular to both the current and the magnetic field. The magnitude of the force increases with the strength of the current and the magnetic field. This is the fundamental principle behind how electric motors work. The interaction between the electric current and the magnetic field produces motion, converting electrical energy into mechanical energy. For this experiment, we'll need a copper wire, a battery, a neodymium magnet, and some paper clips. Yes, paper clips. They're not just for holding papers together anymore. We'll tape the paper clips to the battery terminals like a DIY pro. Next, we'll rest the copper wire on top of the paper clips and bring our contraption close to the neodymium magnet. Now, the moment of truth. Will the wire start moving on its own? Spoiler alert, it does. And as you can see, it's moving quite smoothly. Now, for our grand finale, we'll use everything from the previous setup, but with one small twist. We're going to coil our copper wire into a loop, turning it into a fancy coil. But wait, there's more. On one end of the wire, we'll strip the insulation on only one side. A little trick to keep things interesting. In an electric motor, it's crucial that the current doesn't flow continuously but switches direction. That's usually where commutators come in to save the day. So, let's throw it all together and see if it works. And guess what? It does. We've officially built a simple motor, and it's running. Thanks for watching. If you enjoyed this video and found it helpful, don't forget to hit that subscribe button for more cool experiments and explanations. I've got plenty more coming your way. See you in the next one.